If I wanted to make a scale copy of this rectangle here, either bigger or smaller, then I would multiply each of the sides of the first rectangle times some number to give me the new side. In this case, to go from a 2 to a 4, I multiplied by 2, and that's called a scale factor. Looking at the base of the rectangle, I start with a 6. If the scale factor is a 2, then I would multiply 6 times 2 to get a 12. So a scale factor is a number I multiply by. But what if what I was doing was going from the bigger one to the smaller one? Well, you would be tempted to say that 4 divided by 2 is 2, but since a scale factor is something that I always multiply by, what I'm going to do is I'm going to set up an equation 4 times some unknown number equals 2. Because I'm going from the 4 to the 2. So I have to multiply 4 by something I don't divide. So to solve this one-step equation, I divide both sides by 4. And what I get is x equals 2 over 4, or x equals 1/2. And if you remember from the prior problem, our scale factor was 2. This time, it's the reciprocal of 2. It's 1/2. So 4 times 1/2 gives me a 2. Now here, we're given two figures and we're asked to find what the scale factor is. Well, in describing these, I want to call this one A, and I'm going to call this one A prime. And that's not an exponent over 1, that's a sideways slash. So this one we'll call A, this one we'll call A prime. And to go from this figure to this figure, I want to know what number do I multiply 20 by? Well, 20 times some number is going to give me 30. Well, to find the scale factor, I would then divide both sides by 20. And then I would have x equals 3 over 2. So my scale factor is 3 over 2. Now here we're given figure A and A prime. And this time we see that going from A to A prime that we're increasing in size. So this is also called a dilation when we change size. And to go from the smaller to the bigger, it's still going to be a number I multiply by. So I'm going to pick the 3 and the 9 here because those are corresponding sides. So I have 3 times some number equals 9. Well, this one, just looking at it, we can tell that that's 3. But if we just divide both sides by 3 here, what we get is x equals 3. So that's our scale factor. Now, this one's a higher level of difficulty because there isn't a whole number that I'd be able to multiply 40 by to get 12. So we'll just go ahead and we'll set up an equation. The original side times some number I don't know equals 12. This is a one-step equation, so I divide both sides by 40. Then I'm going to reduce the fraction 12 over 40. So 4 goes into 12 3 times, and 4 goes into 40 10 times. So my scale factor is 3/10. Now, if I was to go from the smaller to the bigger, say this one here, instead of being A prime, this one was A, and this one was A prime, going from the smaller one to the bigger, well, then I would start at 12 times some number equals 40. Now when I divide both sides by 12, are you able to see the pattern? Well, this time it's 40 divided by 12, which is going to be 10 over 3. Notice that it's the reciprocal. On this one, figure A is dilated or scaled up to be A prime. So I want to find the scale factor going from 3 to 6. And we notice that 3 times some unknown number gives us 6. And when we divide both sides, we get x equals 2. So my scale factor is a 2. Now, if this one was A and this one was A prime, then going from the bigger to the smaller, we noticed before that it was just the reciprocal. So let's test to see if that's true. Let's see if it's 1/2. So what I do is I'm going to go from 6 down to 3. So 6 times some unknown number equals 3. And when I divide both sides by 6, this time I'm going to get x equals 1/2. So the scale factor going from the bigger to the smaller is the reciprocal of going from the smaller to the bigger. Since we already have the two figures already drawn, let's take a look at perimeter and area as it applies to scale factor. So for the perimeter of the smaller one, we'll fill in all the sides here. For the perimeter of the smaller one, we have 4 plus 4 is 8, plus 6. 8 plus 6 is 14. The perimeter of the larger one is 16 plus 12, so that's 28. Now, we notice that the perimeter of the smaller one times the scale factor of 2, that 14 times 2 is 28. So it is true that when we know the scale factor and we can find the perimeter of the smaller figure, then when we have a scale copy that has a scale factor of 2, its perimeter is also multiplied by 2. Let's take a look at the area. Over here, we have the area is base times height, so 12. And over here, we have base times height, which is 48. Now, to go from the 12 to the 48 was times 4. And the rule here, if you haven't seen the pattern, is that for area, it's the square of the scale factor. So if I know the scale factor is 2 and I square it, it's 4, then this works. Let's take a look at another one to test this theory. So in the original figure, I'm going from a 2 to the scale copy, which is an 8. So the scale factor is 2 times some unknown number equals 8. And I divide both sides by 2. So what I get is a scale factor equals 4. So if I find the perimeter of the smaller one and all the sides are 2, so the perimeter here is 8, multiplying by 4 would give me the perimeter for this one, which would be 32. Let's test that. So if all the sides are 8 on this one, adding up all 4 sides gives me a 32, so that checks out. Let's test it now for area. So for area, if we take the scale factor and square it, it should be multiplied by 16. So the area of the small one, it's a base of 2 and a height of 2, so the area is 4. So if I multiply 4 times 16, I would get 64. And over here, this is a square, and if I check, 8 times 8 is 64. So for scale copies, to get the perimeter of a scale copy, you use the scale factor. And to get the area of a scale copy, you use the square of the scale factor.